you, that's good. Okay, 7.2 we're going to do relating the characteristics of an exponential function to its equation. Okay, so let's graph these functions. So e to the x, so e is just a number, and it's used for like the naturally decaying process or naturally exponential functions just in the real world get used. If you think about it as a number, if you want to find it on your calculator, it is right here, e to the x. It's the second function, that e to the, and you have to put it to the 1. E to the 1 is about 2.7-ish. It's kind of like using a pi, right? Pi is actually a number, like 3.14. Okay, so let's graph it. So insert that e to the x. Okay, we could zoom 6 it and then adjust if you want. So that is pretty good. We can see what's happening. So what do we know about the x-intercepts? There are none, because it's going to never hit 0. It gets close but never hits. The y-intercept, so I'm going to trace 0. It should be 1, because anything to the 0 is 1. And behavior, so going from quadrant 2 to quadrant 1, we're increasing. The domain, negative infinity to infinity, it goes forever. It kind of flattens, but it keeps going, and then forever. Where x is the element of the reals. And the range, we go from about 0 to infinity. We don't equal 0. Okay, next one. So I'm going to go 9 as a coefficient, and then 2/3 to the x. Okay, I'm just going to graph on the basic grid here and see what happens. And this time we are decreasing. So I'm just going to change my window there. I'm going to make, maybe I'm going to go up to like 20. Just so we can see a little more. There. So what did I know? I know it was going to be decreasing because my base is less than 1. So if you have a fractional base or a decimal base, you're going to actually be a decreasing function. Okay, so the x-intercepts, there's none. And then your y-intercept, the prediction is 9, because this, anything to the 0 is 1 times 9. So to check, we'll hit trace, and then it's actually on that point, but we can go 0, enter, and it's 0, 9. End behavior, when we go from quadrant 2 to 1, we're actually decreasing. The domain and the range are going to be the same. So negative infinity to infinity, and then for y, we are from 0 to infinity. Okay, next. Match this graph with one of those 4 functions. So what's the things we know? We know it's increasing. So what do we know about the base? The base should be greater than 1 if you're increasing. And we know the y-intercept equals 2, so that means our coefficient should equal 2. Okay, so I see a 2 on those, 2 and a 2, and because I want my base to be greater than 1, I can't have that, so the answer is therefore B. Okay, out of these 4 graphs, which one matches this? Okay, so this time it's a little bit different. This -2 makes my graph of 2 to the x shift down.
Coming to practice, pal? Right on. We'll see you there.
We cut the stick. I'm good to go today.
It's going to be busy out there today. Novice girls and us.
Yeah, that will be.
That's 7 and 8-year-old girls. They have a novice girls team, and they need more practice ice because they don't have their own slot. So we invite them to Fridays.
Sweet.
So we have 6 stations today, and 6 minutes per station. And the last 20 we have 2 cross ice games going, and the girls take the far end.
Okay. We good?
So you play a little game.
Okay, so we're going to graph that, and we know it's an increasing function. And we'll know that it has a y-intercept of 1. But then you're going to take that and you're shifting it all downward 1. Okay, so I know it's not that because that decreases. And so, well, this one looks like it's going to be the 1 because it's increasing, and think about that all shifting down 2. So my y-intercept went down 2, my asymptote here went down 2.